All right, let's talk about AI coding assistants. You know, tools like ChatGPT and GitHub Copilot. They're everywhere, and they promise to completely change how we develop software. But there's a catch. Some really eye-opening research from LUT University has uncovered a hidden dark side. It turns out these incredible tools might actually be injecting serious security risks right into our code without us even realizing it. So let's get into it.
So here's the fundamental problem, right in a nutshell. On the one hand, you have the promise. These assistants are amazing. They boost productivity, help us code way faster, and let us hit those crazy deadlines. But on the flip side, there's a huge peril. The exact same tools can generate code that is riddled with hidden and sometimes really severe security flaws.
And look, this isn't just some vague worry. This quote from the research lays it out crystal clear. Large language models, or LLMs, they just don't do secure coding practices by default. And that's the key phrase. It means if we're not adding extra security checks ourselves, we're basically rolling the dice and risking shipping vulnerable code out into the world.
So yeah, it's a real double-edged sword. There's no doubt developers are embracing these things. I mean, they're like having a virtual mentor sitting next to you, speeding everything up. But we have to look at the other side of that sword, the one that can cut deep into our application security. We need to understand exactly how that happens.
This chart really tells the story, doesn't it? An overwhelming majority, you see 84%, say their work experience has improved. 75% say it's helped them meet deadlines. That's huge. But hang on, look closer at the other numbers. You've got folks saying the AI is really only useful for generic stuff, or that its output needs a ton of review. And that right there, that's our first big clue that blindly trusting these tools is a really bad idea.
So this begs the question, right? If these AI models are so incredibly smart and advanced, why on earth are they making these basic security mistakes? How does a good AI end up learning such bad habits?
Well, the answer is actually pretty straightforward. It all boils down to that old saying, you are what you eat. So first off, these models are trained on absolutely massive, completely unfiltered collections of public code from places like GitHub. Now second, that public code is, let's be honest, full of insecure patterns, old habits, and outdated practices. And finally, the AI doesn't judge, it just learns. It memorizes all of it, the good, the bad, and the ugly, and then it spits those same flaws right back out in its suggestions to you.
And this is so important to understand. We're not talking about random one-off bugs that just pop up. No, these are systemic, predictable patterns. The AI is just echoing the mistakes it learned from all that historical code. And that makes these flaws both super dangerous, but also, and this is the good news, it means we can learn to identify them.
Now, if you want a number to really understand the scale of this problem, here you go. A major study that was cited in this research found that a shocking 40%, 40, of AI-generated code suggestions had security vulnerabilities. Almost half. Just let that sink in for a second.
So what do these flaws actually look like? Well, the LUT University research analyzed a whole bunch of studies and found that 4 big categories of security flaws just kept showing up again and again, no matter the AI model or the programming language. So let's call them what they are, the 4 horsemen of flaws.
First up, we have input validation and injection weaknesses. Okay, think of it like this. It's like having a security guard for a building who just lets absolutely anyone walk in without checking their ID. The AI often writes code that doesn't check if what a user is typing in is actually malicious code. And that opens the door wide open for attacks that can lead to data being stolen or even an attacker taking over the whole system.
Our second horseman is all about cryptographic and authentication weaknesses. Basically, this is about handling secrets badly. The AI might suggest using some old broken encryption method or, and this one is a classic, it'll hard code things like API keys and passwords right there in the open in the source code. It's the digital version of leaving your front door key under the doormat.
Third is memory safety and resource errors. Now, these are a bit more technical, and you see them a lot in languages like C and C++. These are deep-seated flaws where the code just doesn't manage the computer's memory correctly. And the result? It can be anything from your app just crashing to a really serious buffer overflow attack that a hacker can exploit to run their own code.
And the final horseman is insecure file and error handling. This one can be pretty subtle, but it's just as dangerous. This is where the AI spits out code that messes up file permissions, or even worse, when something goes wrong, the error message it creates accidentally leaks sensitive information about your system. It's like giving an attacker a treasure map to all your weaknesses.
Okay, I know that is a whole lot of doom and gloom.
But here's the good part. The research is very clear that the answer isn't to just throw these amazing tools away. Not at all. The solution is to get smarter about how we use them. It's all about building a workflow that has security baked in from the very beginning.
And this right here is the core idea. It's called a human-in-the-loop framework. If you take away just one thing from this, let it be this. You cannot, ever, blindly trust the AI. The developer, the human, has to be the final boss, the one who applies critical thinking to every single piece of code the AI suggests.
So the research actually gives us a really practical 3-step plan to do this. Step 1, security-aware prompting. Be specific with the AI. Don't just say, write me a function. Say, write me a secure function that validates all user input. Step 2, use static analysis tools. These are automated scanners like CodeQL that are built to find these exact kinds of known security flaws. And step 3, and this one is absolutely non-negotiable, mandatory human code review. A real experienced human developer has to look at and approve any AI-generated code before it gets anywhere close to being released. Which brings us to this final question, and it's something every single one of us using these tools needs to think about. Is your AI assistant a helpful partner, making you a faster, better coder? Or is it, without you even knowing, a security liability that's quietly introducing risk into your work? The research is pretty clear that without the right checks and balances, it could easily be both. And knowing the difference, well, that responsibility is on us.